All right, here we go. To the nearest tenth of a degree, solve 3 times cosine of theta plus 9 equals 7. And our range here, our domain is going to be 0 degrees to 360 degrees. Now, I really think that if you pause this video, go back and think through the first problem, the first video, that you'll be able to get to the answer on your own. And I think that it's going to be and then watch the video for kind of confirmation that you're doing it. But I think that's going to be the best way for you really to learn through this, is learning by kind of doing and just practicing. So please do pause the video and then come back and check your work after that. So I hope that you have paused at this point. And here we go. So thinking of cosine, or the inverse of cosine. The inverse of cosine, its domain is from 0 to 0 to 180 degrees. Our cosine is the one that is in the first and second quadrant. Here our x values are positive, here they're negative, no repeating values there for x. So we're from 0 to 180 degrees. All right, so knowing that, let's come back and kind of approach this problem. So we've got 3 times the cosine of theta plus 9 equals 7. So just approach this just like you would with a regular equation. We're going to try to isolate the trig function. We're going to try to isolate this right here, just like you would in x. So isolate the trig function first. Got to do that first. All right. So if this said, for example, 3x plus 9 equals 7, what would you do? Well, you would subtract 9 from both sides and then divide by 3. And that's exactly what we're going to do right now. So first subtract both sides, 9 from both sides. That leaves us with 3 times cosine of theta equals negative 2. Now we're going to divide both sides by 3. And we get that cosine of theta equals negative 2/3. All right, and so from there, let's find out what that angle is. So we're going to do our inverse trig functions, specifically for cosine. So the inverse of cosine is equal to negative 2/3. There we go, and you get 2.3. Oh, we're supposed to be in, my bad, we're supposed to be in degrees. Let me switch my mode. All right, let's try that one more time now. So inverse cosine of negative 2/3. There we are. 131.8. Because we're rounding to the nearest tenth. 131.8. All right, is that the next one? No, it's the nearest tenth. There we go. Nearest tenth. So our value for theta is equal to 131.8 degrees. All right, now let's think through that for a second. That is at 131, somewhere over here, 131.8 degrees. But we need to know what the reference angle here is, so that we can also find, well, where else would cosine be equal to negative 2/3? Because it's outside of our domain, but we would also have negative 2/3 right here. So we'll find this reference angle and then add that to 180, and then we'll know what this new angle is. So let's go through that. 180 degrees minus 131.8. And what's that going to give us? 48.2. So 2. So borrow 2. 8, bring down that decimal, and 4. Okay, so 48.2 degrees is our reference angle. All right, to find our second angle, the one in the third quadrant, it's going to be 180 degrees plus that same angle. So now we're going to do 180 plus 48.2. So let's see, 228.2. So let's go and write out our values. So we know that theta is equal to, well, in quadrant, let me kind of clear the space back up. In quadrant 2 and in quadrant 3 is where our two answers lie. And so in quadrant 2, we have 131.8 degrees. And then in quadrant 3, we have 228.2 degrees. So there's our two answers within the domain of the problem, and being able to work kind of backwards from knowing that the domain of the inverse of cosine is limited. So I hope that helps, and yeah, hope it helps.